Hello everyone, welcome to Concepts in Chemistry YouTube channel and also welcome to the new series that is multiple select questions or MSQ series. So this series of questions usually we will see in GATE and IIT-JAM exam, but this MSQ or multiple select questions series of questions will also be helpful for any other competitive exam like CSIR-NET, BARC or any other MSc entrance exam. So but since we usually see in GATE or IIT-JAM exam this type of MSQ questions, so that's why we can say this series of questions is special for GATE and IIT-JAM aspirants. But again, I am telling you that this type of questions is also very important for other competitive exam like CSIR, NET, BARC or any other competitive exam regarding chemical science subject. So yeah, we already discussed one questions from in the series MSQ series. This is the second questions or second video in MSQ series. So you will find somewhere the I button to please click to see the first questions. So now let's see the second question in MSQ series. That is from Chemical Thermodynamics. So let's see the question. So MSQ question number 2. So the correct option is oblique R. So you all know that इस टाइप जो क्वेश्चन होता है MSQ मल्टीपल सेलेक्ट क्वेश्चंस. सो इस टाइप का क्वेश्चन में आंसर जो होता है उसमें मैक्सिमम केस में मोर देन वन ऑप्शन सही होता है. सो 4 ऑप्शंस गिवन होता है, उसमें से मैक्सिमम मींस 95% केस में और 98% केस में मोर देन वन ऑप्शन करेक्ट होता है. इसलिए नेम MSQ मल्टीपल सेलेक्ट क्वेश्चंस. बट 1% देयर विल बी 1% चांस होता है जिसमें एक ऑप्शन करेक्ट होता है. बस मोर देन 98 और 99% केस में मोर देन वन ऑप्शन करेक्ट होता है, इसलिए इसका नाम है MSQ सीरीज. So let's read the question. So four statements are given, so we have to find which on or which are the correct statements. यूजुअली मैक्सिमम केस में MSQ सीरीज में ऐसे ही स्टेटमेंट दिया हुआ स्टेटमेंट हम लोगों को मिलता है, 3-4 स्टेटमेंट और स्टेटमेंट के 3-4 स्टेटमेंट होता है, उसमें से कौन सा स्टेटमेंट करेक्ट और कौन सा स्टेटमेंट रॉन्ग हम लोगों को फाइंड करना होता है. सो लेट्स रीड द फोर स्टेटमेंट, देन वी विल डिस्कस डिटेल्स about these four statements, and at last we will see which are the correct and which are the wrong statement given. So the first statement uh, says that isothermal free expansion of an ideal gas is an example of adiabatic process. So isothermal free expansion of an ideal gas is an example of adiabatic process. First read the four statement, then we will see one by one, and we will explain details about these four statements given. An adiabatic free expansion of an ideal gas is a constant energy process. So statement A and B somewhat similar kind of. Isothermal free expansion of an ideal gas is an example of adiabatic process. Adiabatic free expansion of an ideal gas is a constant energy process. For the process, melting of ice at 0 degree centigrade and at 1 atm pressure, del G equal to del A. So for this process, melting of ice at 0 degree centigrade and 1 atm pressure, we can write del G equal to del A. Is this correct or wrong? We will see later. Statement 4. Spontaneous polymerization is an example of endothermic process. So these are the four options. Now let's discuss one by one details about these four statements. So first, isothermal free expansion of an ideal gas. Condition is isothermal free expansion ideal gas is example of adiabatic process. So discuss the first statement. So we know we all know the first law of thermodynamics, that is dE, or you can write du. E and u same, that is internal energy, or dE means change in internal energy. dQ plus dW, this cut means this q term is not a state function. So E is a state function, that's why simple D, but D cut we used for in the case where the function are not state function. So Q and W are not a state function. That's why we used to write here cut, D cut. So yeah, this is the first law of thermodynamics. We all know the equation of first law of thermodynamics. Now for ideal gas, we all know for ideal gas we can write dE or du. Same thing, equal to NCV bar dt. CV bar equal to molar heat capacity. If you want to write only CV dt, then you have to write only CV dt, not N. If you want to write N CV dt, then that is wrong. N CV dt is wrong. Either N CV bar dt or simple CV dt. For D, likewise we can write DH, that is enthalpy change, equal to NCP bar dt or simple CP dt. You cannot write CP bar dt. If you write CP bar, then you have to write NCP bar dt. Means molar heat capacity means CP bar upon N. CP bar or CB upon N means molar heat capacity. So CP bar or CV bar means CP upon N. That's why we write here N CP bar dt. So we all know that is a simple expressions. We all know dE for ideal gas. Obviously for ideal gas, we can write dE equal to N CP bar dt or CV dt. For D and dA is equal to CP dt or N CP bar dt. So see in the first statement, isothermal free expansion of an ideal gas. Ideal gas is given. That's why we write for ideal gas dE equal to, we can write N CP bar dt equal to dQ plus dW. Now see, isothermal condition and also free expansion condition is given. So let's see what happens now. For isothermal process, you all know that isothermal process means T constant. If T constant means dt equal to 0. So for isothermal process, we can write dt equal to 0. Again for free expansion, because in the questions isothermal free expansion is given. So also for free expansion, so free expansion means gas expands freely. There is no external pressure. There is no external pressure means P external equal to 0. So from these equations, dW equal to minus P external dV. So since P external is 0 for free expansion, that's why dW will be 0. So for isothermal process, dt equal to 0. For free expansion, so free expansion means there is no external pressure. Since there is no external pressure, so P external equal to 0. That's why we can write dW equal to minus P external dV. So this is 0 means dW also 0. So from equation 1 we can write NCV bar dt equal to dQ plus dW. From these equations we can write dQ equal to 0. dQ equal to 0 means dW 0 and dt 0. So for isothermal process, dt 0 means this term becomes 0. For free expansions, dW 0. So simple mistake, that is, so when we want to write W or Q, we have to put a cut in D. We cannot write simple D. So we can write simple D for state function. ds, dAs, dt, dV, not for W and Q. So see from equation on, dW is 0 and this side dt becomes 0. CV is also constant, n is constant. So CV का जो वैल्यू होता है वो एक कांस्टेंट वैल्यू होता है, उसका जीरो नहीं होता है और n भी जीरो नहीं होता है. So dt 0 means this whole term becomes 0. So from this equation we can write dq equal to 0. So dq equal to 0 means we can write q is equal to constant. So dq equal to 0 or q is equal to constant. This is the condition for adiabatic process. We all know that for adiabatic process q is equal to constant or dq is equal to 0. Simple equation, first law of thermodynamics, we can write for ideal gas NCV bar dt equal to this. Now for condition is given in the first statement, that is that the process is isothermal free expansion. For isothermal process dt becomes 0, that is this term whole becomes 0. For free expansion के केस में p external 0 होता है, that's why dw equal to minus p external dv, this term will be 0, so the dw term becomes 0. Now from equation 1 we can write dq is equal to 0 0, so dq is equal to 0, or we can write q is equal to constant. So this is the condition of adiabatic process. So if we found that isothermal free expansion of an ideal gas is an example of adiabatic process. So the first statement is correct statement. Now second, adiabatic free expansion of an ideal gas is a constant energy process. So let's see. So adiabatic free expansion दिया हुआ है क्वेश्चन में, द प्रोसेस इज एडियाबेटिक फ्री एक्सपेंशन. सो सेम थिंग फ्रॉम द फर्स्ट लॉ ऑफ थर्मोडायनामिक्स we can write this equation. This is the expression of first law of thermodynamics. Now we just saw that for adiabatic process we can write dq is equal to 0 or q is equal to constant. For free expansion we can write dw equal to 0. So second case, see, in first case isothermal free expansion was there. In second case, just in place of isothermal they write here adiabatic free expansion. So adiabatic process dq 0, for free expansions dw 0. So from this equation we can write d equal to 0, means dq 0 for adiabatic process, dw 0 for free expansions, so we can write d is equal to 0. So for ideal gas again we can write d is equal to n cv bar dt equal to d equal to 0. So from this expression we can write cv bar cannot be equal to 0, means it should have some value cv bar. n also, n का वैल्यू 0 नहीं हो सकता है, एटलीस्ट 1, और n का कोई कांस्टेंट वैल्यू होगा. n का वैल्यू कभी भी 0 नहीं हो सकता है, cv bar का वैल्यू कभी 0 नहीं हो सकता है. सो फ्रॉम दिस एक्सप्रेशंस वी कैन राइट dt equal to 0. So dt equal to 0 means t is equal to constant. So this is the condition for isothermal process. Also, since d is equal to 0, d is equal to 0 means we can write e is equal to constant. So we can say that this is a constant energy process. So see the statement 2, adiabatic free expansion of an ideal gas is a constant energy process. Yeah, we saw here. From these expressions we found d is equal to 0. So d is equal to 0 means we can write n cv bar dt equal to 0. n cv bar dt equal to 0 means we can write dt equal to 0, because cv bar and n cannot be equal to 0. So this is the condition for isothermal process. Again, since d is equal to 0, we can write e is equal to constant. So it is a constant energy process. So option 2 or statement 2 is also correct. Now see, if someone कोई भी एग्जाम में अगर ये वाला कांस्टेंट एनर्जी प्रोसेस वाला ये वाला टर्म ना लिख के अगर वो लोग मेंशन करते हैं adiabatic free expansion of an ideal gas is an example of isothermal process, then also the statement 2 will be correct. See case 2, we found this is the condition of isothermal process, and also since it is isothermal means d is 0 and dt is 0. dt 0 means we can say d is 0. dt 0 means we can say ncb dt 0. ncb dt 0 means we can say d is 0. d is 0 means e is constant. So this is a constant energy process. So ये वाला स्टेटमेंट और एक तरीका में लिख सकते हैं हम, adiabatic free expansion of an ideal gas is an example of isothermal process or is a example of constant energy process. Both are same, and we justified via two expressions, dt is equal to 0 and d is equal to 0. dt 0 means t constant, isothermal conditions, D 0 means E constant, constant energy process. So अगर ये वाला स्टेटमेंट में अगर ऐसा कुछ लिखा हुआ होता adiabatic free expansion of an ideal gas is a constant energy process, instead of adiabatic free expansion of an ideal gas is an example of isothermal process, then that then this statement will also be correct. So स्टेटमेंट ए एंड बी हम लोगों ने देखा दोनों ही करेक्ट स्टेटमेंट है. अगर इन प्लेस ऑफ कांस्टेंट एनर्जी प्रोसेस we can write here also this is a example of isothermal process. So isothermal free expansion of an ideal gas is an example of adiabatic process. Adiabatic free expansion of an ideal gas is a isothermal process, or you can say constant energy process. See, the two statements are similar, इसमें थोड़ा चेंज है. फर्स्ट केस में हम लोगों को कंसीडर करना पड़ेगा आइसोथर्मल फ्री एक्सपेंशन, सेकंड केस में एडियाबेटिक फ्री एक्सपेंशन. फर्स्ट केस में जो रिजल्ट आएगा वो आएगा एडियाबेटिक प्रोसेस, सेकंड केस में जो रिजल्ट आएगा वो आएगा आइसोथर्मल प्रोसेस और कांस्टेंट एनर्जी प्रोसेस. सो हम लोगों ने देखा ए एंड बी स्टेटमेंट आर करेक्ट. नाउ लेट्स सी द सी स्टेटमेंट. फॉर द प्रोसेस melting of ice at 0 degree centigrade means 273 Kelvin or at 1 atm pressure, del G equal to del A. Now let's see for this process del G equal to del A होता है और नहीं होता है. So we all know for melting of ice del V or dV term is negative, means volume change is negative. So ice का volume ज़्यादा होता है water से, that's why when ice melt into water so the volume decreases, that's why dV negative. So for melting of ice we can write dV or del V is equal to negative. Now we all know that is Gibbs free energy equal to H minus Ts. So G equal to H minus Ts. So again we know H is equal to E plus PV. So here we can write E plus PV in place of H. So now minus Ts. Again we know A, that is Helmholtz free energy equal to E minus Ts. So E minus Ts we can write as A plus PV. So now if we consider the change in these functions, for these functions del G become del A plus P del B. हम लोगों ने इसमें P में चेंज क्यों नहीं कंसिडर किया? See in the questions for the process melting of ice at a particular temperature T constant and 1 atm pressure, they mentioned 1 atm pressure means pressure constant for this process. For this process we have to consider constant pressure, means they mention in the statement 1 atm pressure, and also 0 degree centigrade means 273 Kelvin. So that's why we are writing here P del V. So P constant. हम लोग इसमें P का चेंज नहीं कंसिडर कर सकते क्योंकि स्टेटमेंट में दिया हुआ है P constant. So we can write del A plus P del V. If we consider this change in this term G and this term, then we can write del G equal to del A plus P del B. P का change consider नहीं किया क्योंकि in the questions it is given that 1 atm pressure means pressure is constant for this process. So now we can write del G minus del A equal to P del B. Del G minus del A equal to P del B. Now del G minus del A. So we saw that for this process melting of ice del V equal to negative. So del V equal to negative and P प्रेशर का वैल्यू कभी नेगेटिव नहीं हो सकता है. सो P का वैल्यू इसमें तो मेंशन किया हुआ है 1 atm, बट प्रेशर तो कभी नेगेटिव नहीं हो सकता है, प्रेशर पॉजिटिव होता है. बट ये क्वेश्चन में भी मेंशन ही है P का वैल्यू है 1 atm प्रेशर. सो दिस होल टर्म बिकम नेगेटिव. नाउ del G minus del A become negative. The subtraction del G minus del A become negative. So we can say del G is less than del A. That's why this subtraction become negative value. If del G greater than del A, then this subtraction become positive result, give positive result. Now since del G less than del A, that's why it will give negative result. So we can say for melting of ice at 0 degree centigrade and 1 atm pressure, del G less than del A. So in the options C, for the process melting of ice at 0 degree centigrade and 1 atm pressure, del G not equal to del A, del G less than del A, del G less than del A. So gives free energy लेस देन इक्वल टू हेल्महोल्ट्ज फ्री एनर्जी. सो हम लोगों ने ये जस्टिफाई कर लिया via इक्वेशंस. So for melting of ice, del V negative, we all know this thermodynamic state of equation. G is equal to H minus Ts. We all know H is equal to E plus PV. We can write E plus PV minus Ts. We all know Helmholtz free energy is equal to E minus Ts. So E minus Ts become A plus PV. Now if we consider the change of this all term, del G become del A plus P del B. P is constant, that's why we cannot consider the change in P. So now del G minus del A become P del B. P का वैल्यू इसमें 1 है, del V नेगेटिव है फॉर दिस प्रोसेस, सो दिस होल टर्म बिकम नेगेटिव. Since del G minus del A negative, so we can say del G less than del A. So the statement 3 is wrong statement. Now see the statement D. Statement D में क्या लिखा हुआ है? Spontaneous polymerization is an example of endothermic process. Spontaneous polymerization is an example of endothermic process. See, we know again that G is equal to H minus Ts. So at constant temperature, if we maintain, if we consider constant temperature, then if we want to write the change of this term, del G equal to del H minus T del S. So at constant temperature, we can write del G del H minus T del S, like the previous one. हम लोगों ने उसमें प्रेशर को कंसीडर कर ली, प्रेशर को कंसीडर करना ही था क्योंकि प्रेशर कांस्टेंट मेंशन था क्वेश्चन में. इसमें हम लोग एक इक्वेशन लिख रहा है जिसमें हम लोगों ने कांस्टेंट टेम्परेचर कंसीडर करके ये वाला इक्वेशन लिख रहा है, del G इक्वल टू del H माइनस T del S. So for spontaneous process, you all know, for spontaneous any spontaneous process, del G इक्वल टू नेगेटिव, you all know. del G जिसमें नेगेटिव होता है वो वाला रिएक्शन फॉरवर्ड में प्रोसीड होता है, वो वाला रिएक्शन स्पॉन्टेनियस होता है, वो वाला प्रोसेस स्पॉन्टेनियस होता है. ये यूनिवर्सल ट्रूथ है, ये हम लोग सभी को पता है. फॉर स्पॉन्टेनियस प्रोसेस del G नेगेटिव, एंड फॉर पॉलीमराइजेशन प्रोसेस, सी हम लोगों ने अगर पॉलीमर रिएक्शन देखा तो 3, 4, 5 और 10, 20, 50 मोनोमर मिलके एक पॉलीमर बना रहा है. सो इस वाला केस में एंट्रोपी डिक्रीज हो रहा है. बहुत सारा मोनोमर, मोर देन 100,000 मोनोमर मिलके एक पॉलीमर फॉर्म नॉर्मली करते हैं. सो पॉलीमर में क्या होता है? एंट्रोपी लॉस, एंट्रोपी लॉस बहुत होता है. पॉलीमराइजेशन रिएक्शन में एंट्रोपी लॉस बहुत ज्यादा होता है बिकॉज 100,000 of monomer polymerized to give a polymer, a large molecular weight that contain polymer. So in polymerization process, the del S value is negative. So in polymerization process, entropy decrease होता है. So del S value is negative for polymerization process. Any polymerization process, del S value is negative. So from this equation, we can write del H equal to del G plus T del S. So del G is negative for this spontaneous polymerization process. For spontaneous process, del G negative. For polymerization process, del S negative, and also T is a positive value. Temperature can be negative. Temperature is a positive value. So we have to consider here temperature is a positive value. So temperature का value तो negative होता है कभी-कभी, but spontaneous process of polymerization process, so we have to consider here temperature is a positive, and since del G is more negative, and also this del S is also more negative. So टेम्परेचर अगर हम लोगों ने टेम्परेचर पॉजिटिव कंसीडर कर लिया, टेम्परेचर पॉजिटिव, हाँ पॉजिटिव कंसीडर करना होगा इस केस में. सो सी द स्टेटमेंट अगेन. So spontaneous polymerization is an example of endothermic process. So polymerization reaction polymerization reaction में टेम्परेचर जो होता है वो पॉजिटिव होता है, नो नेगेटिव टेम्परेचर. polymerization रिएक्शन के केस में हम लोगों को और नॉट रूम टेम्परेचर, मोर देन रूम टेम्परेचर में रिएक्शन करना पड़ता है. सो T is positive. So for this case, spontaneous process del G is large negative, del S for polymerization process is large negative, and T is also positive. So that's why this whole term become negative. So del S become negative means condition for exothermic process. So you will see that any polymerization process, so polymerization process negative temperature means low temperature में नहीं होता है, high temperature में, that's why T positive, so this whole term become negative, also this whole term become negative, so this whole two term overall give negative result, that's why delay is negative means this is a exothermic process. बट क्वेश्चन में क्या क्या दिया हुआ है, क्वेश्चन में मेंशन किया गया है spontaneous polymerization is an example of endothermic process, so it is wrong. With that saw and proof that spontaneous polymerization spontaneous polymerization is an example of exothermic process. Delay is negative mean exothermic process. So for spontaneous process del G negative, for polymerization process always delay is negative, that's why from this equation delays become negative. So it is a condition for exothermic process, not endothermic process. So option A is correct. We saw and we justified via thermodynamic equation of state. Isothermal free expansion of an ideal gas is an example of adiabatic process. प्लीज ये वाला स्टेटमेंट आप लोग याद कर लीजिएगा, कभी भी ये वाला स्टेटमेंट के थ्रू कभी भी कहीं भी एग्जाम में, कॉम्पिटिटिव एग्जाम में क्वेश्चन पूछ सकते हैं, नॉट फॉर एमएसक्यू, एमसीक्यू और एनी अदर जो क्वेश्चन होता है उसमें पूछ सकते हैं. Adiabatic free expansion of an ideal gas is a constant energy process or it is a example of isothermal process. ये वाला स्टेटमेंट प्लीज याद रखिएगा हमेशा. For the process of melting of ice at 0 degree centigrade and 1 atm pressure, del G not equal to del A, del G less than del A. We also verified this and justified via equations that del G less than del A. And spontaneous polymerization is an example of endothermic process. It is also wrong. Spontaneous polymerization is an example of exothermic process. We also verified that. So yeah, thank you guys. That's all for these questions. MSQ question number 2. So I hope and I believe that ये क्वेश्चन जो हम लोगों ने डिस्कशन किया इसका तो कोई पॉजिटिव इफेक्ट होगा सो आप लोगों के लिए, सो हेल्पफुल भी रहेगा कॉम्पिटिटिव एग्जाम के लिए. एंड बाकी आईआईटी जैम एंड गेट के लिए तो ये स्पेशली है. सो बाकी जो कॉम्पिटिटिव एग्जाम होता है सीएसआईआर नेट बार्क और अदर कॉम्पिटिटिव एग्जाम, सो उसमें भी ये क्वेश्चन बहुत हेल्पफुल होगा. सो थैंक यू फॉर वॉचिंग, थैंक यू फॉर योर सपोर्ट्स एंड please stay tuned, stay safe, stay healthy. So lots of questions on the way, so you will see lots of different type of questions, different type of concepts in chemistry. So yeah, now for now that's all. Again, thank you. Yeah, bye.